Here we have to find out the incorrect statement. We will come from the bottom. In general, sag correction is always negative, it is correct. And the correction for slope is always subtractive, it is also correct. If the pull applied during measurement in a chain surveying is more than the pull out at which tape was standardized, the correction is positive, it is also correct. If the temperature in the field during measurement, the chain surveying is more than the temperature at which the tape was standardized, the correction is positive. But here it was negative. So the incorrect statement is A. Option A is correct. Here in this problem, we have to find out the height of the instrument. Height of the instrument HI is equal to benchmark or reduced level plus backside. So we know the benchmark level, that is benchmark level is 210.5852 plus backside 2.324, that is equal to 213.176 meters. The height of the instrument is 213.176. Option A is correct.
The given function is x square plus 2y square plus z. Now we have to find the directional derivative of this function f at some point 1 comma 1 comma 2. Now the directional derivative of f is given by the formula delta f is equals to I into dou f by dou x plus dou f by dou y into j plus k into dou f by dou z. Now if we substitute, we'll get it as 2xi plus 4yj plus k. Now the directional derivative at the point 1, 1, 2 is nothing but 2i plus 4j plus k. But we need the directional derivative in direction of a bar, that is 3i minus 4j, which is given by the formula. Directional derivative, required directional derivative is delta f dot a by mod a, which is nothing but 2i plus 4j plus k dot 3i minus 4j by root over 3 square plus minus 4 square. If we simplify, we'll get it as minus 2, which is nothing but option. Now in this problem, it is given that eigenvalues of a 2 by 2 matrix are minus 3 and minus 2. Now we have to find the eigenvalues of matrix x plus 5i. Now let the 2 by 2 matrix x, whose eigenvalues are minus 3 and minus 2, be minus 3, 0, 0, minus 2. Now we know 5i. 5i is nothing but 5, 0, 0, 5. Now x plus 5i will add them, which is nothing but 2, 0, 0, 3. Now clearly it's a diagonal matrix. Now in any diagonal matrix, eigenvalues are nothing but the diagonal elements. So the eigenvalues are 2 and 3. That is option C. The given function is f is equals to y power x, and we have to find dou square f by dou x dou y at x is equals to 2 and y is equals to 1. Now apply logarithm on both sides to the given function, that is log f is equals to x ln y. Now in order to find this dou square f by dou x dou y, first we'll find dou f by dou x, that is 1 by f into dou f by dou x, which will give you ln y, since we are differentiating with respect to x. So d by dx of x is nothing but 1. Now which can be written as dou f by dou x is equals to f ln y. Now we differentiate it with respect to y partially. Now that is dou square f by dou x dou y is nothing but, now we'll use UV rule as both are variables. F into differentiation of log y is nothing but 1 by y plus log y into differentiation of f is dou f by dou x, that is equals to f by y plus log y into fx by y. Since dou f by dou y is nothing but fx by y, if we differentiate, you'll get this value. Now, it can be further simplified as y power x by y into 1 plus log y. Now we'll substitute the values of x as 2 and the value of y as 1, which is nothing but 1 power 2 by 1 into 1 plus log 1, which will give you 1, which is nothing but option C. Now, in this problem, we have to find one of the roots of the equation x cube equals to j, where j is nothing but root over minus 1. So it is nothing but a complex number. Now, the given equation is x cube equals to j. We'll convert this complex number into mod ampere form. That is, x cube will be equals to e power j pi by 2. Since j can be written as cos 90 plus I sin 90. Sorry, j sin 90, which is nothing but j. Now, as we need the value of x, send that cube to other side. So x will be e power j pi by 2 whole power 1 by 3. So x is nothing but e power j pi by 6, which can be written as cos pi by 6 plus j sin pi by 6. Now, cos 30 plus j sin 30, but root 3 by 2 plus j into half, which is equals to root 3 by 2 plus j by 2. That is nothing but option B. We have to evaluate the integral z plus 5 by z square plus 2z plus 5 dz. Now, in order to find this integral, we have to find the poles of the denominator, that is z square plus 2z plus 5. In order to find the poles, we'll equate it to 0. Now, the value of z will be minus 1 plus or minus 2i. Now, the value of r is nothing but root over minus 1 square plus or minus 2 square, which will be root 5, always greater than 1. That means these roots, these poles lie outside the unit circle. So if the poles lies outside the unit circle, the value of the integral will be always 0. So therefore z plus 5 by z square plus 2z plus 5 integral will be 0. That is option B.
This problem we have to find out the second moment of area about an axis d by 3 distance above the bottom axis. You will take a rectangle of depth d and width b. We have to find out the second moment of area at a distance of d by 3 from the bottom. We know Ixx, you will take it as an xx. Ixx is equal to ICC plus ax square, ay square. Y is d by 3. ICC is equal to BD cube by 12, we know, and area is B into D, that we know. Y is D by 3 whole square, that is equal to 7BD cube by 36. Here in these options, option C is correct. To find out the maximum shear stress at particular point, maximum shear stress is equal to sigma 1 minus sigma 2 by 2. What is sigma 1 and sigma 2? These are principal stresses. We know sigma 1 is equal to 20 MPa, 30 MPa, and sigma 2 is equal to 20 MPa. So sigma 1 is equal to 30 minus of minus 20 by 2, that is equal to 50 by 2, that is equal to 25 MPa. Answer D is correct.